Okay, so this is example 20, then page 114. Okay, so we've got this diagram. OABC is a parallelogram. P is the point where the diagonals OB and AC intersect. Well, the first thing you need to note that when you're drawing diagrams like this, the points always go either clockwise, the vertices, when you're labeling them, or anti-clockwise, okay? So OABC, I could have done OABC. It makes no difference, but we'll follow the diagram given in the book. And P, you're told that P is the point where the diagonals OB and AC intersect. So what we're saying actually here is that AP is a half of AC if it bisects. And also OP is a half of OB. Well, what we're being asked to do is prove that, so we've got some multiple, some scalar multiple of AC. So AP, we'll say, is some lambda, lots of AC, and OP is some mu lots of OB, some mu lots of OB, where lambda is equal to mu. That's what we're being asked, and we know that it will have to be a half. So what we've got to do is we've got to use the vectors that we're given. We're told that OA is equal to A, and OC is equal to C, respectively, okay? So the way to approach this is that we have to think of OP in two different ways and write two equations down for OP and solve them simultaneously. That's essentially what we're doing. Okay, so basically, in order to continue with this then, we're going to need the vectors AC and OB, okay? So AC is going to be minus A plus C, okay? And OB is going to be A plus C. Because it's a parallelogram, this is going to be C as well. So it's A plus C. So those are the two vectors that we're going to use, and we're going to find OP in two different ways. Okay? Now the first way is by saying that OP is some scalar multiple of OB, and we've used mu. So it's mu lots of OB. So it's mu lots. Now we know that OB is A plus C. So that's the first thing. So now we've got to find OP in a different way. So we know that OP can also be written as OA plus AP. Okay, and where AP is some multiple, remember, of AC. So we've used lambda lots of AC, okay? So we know OA from the diagram is A, and we know that AC from here is minus A plus C, so it's going to be lambda lots of minus A plus C. So we've now got A minus lambda A plus lambda C. So we've now got two equations that we're going to solve simultaneously. So on the one hand, we've got OP is equal to mu lots of A plus C. And on the other hand, OP is equal to A minus lambda A plus lambda C. So what we've got to do now is we've got to equate the coefficients. So this one is going to expand out to be mu A plus mu C. So mu A plus mu C is equal to this one here. A minus lambda A plus lambda C. Okay? Now what I'm going to do here is I'm going to factor this A out. So I've got mu A plus mu C is equal to A times 1 minus lambda plus lambda C. So equating coefficients, we can see, firstly, that mu c is equal to lambda c. So therefore that means mu is equal to lambda. And we're getting close now because we know from looking at the problem earlier on that mu is equal to lambda. Okay. Also, I'm going to write this a little bit down here. We know that mu a is equal to 1 minus lambda a from here. Okay, so therefore, in fact, I don't want to start, I want the therefore, don't I? Sorry. Okay, so therefore, mu is equal to 1 minus lambda. And since lambda is equal to mu, okay, then obviously mu is equal to be 1 minus mu. So 2 mu is 1. So mu is equal to a half, which is also equal to lambda. So we've proven that AC is bisected by the point P and OB is bisected by the point P. Please remember that we are not showing that OP is the same length as AP. We're not showing that at all. We're just showing that OB is bisected by the point P and AC is bisected by the point P. Okay?